Now there are three rhumb-line sailing methods. These are parallel sailing, plain sailing, and Mercator sailing. There are two more sailings in navigation, and those two more sailings are great circle sailing and composite sailing. Great circle sailing and composite sailing involve complicated concepts of spherical trigonometry. Also, when we are moving on a great circle track, a composite track, the course of the vessel keeps on changing continuously, making the sailing complicated. The rhumb-line sailings, on the other hand, have the advantage of being the simplest form of sailing. Vessels move on a straight line track. The course of the ship remains the same right from the departure to the destination. Let us now go into these rhumb-line sailings one by one. Now the first sailing, rhumb-line sailing, which we have is parallel sailing. Parallel sailing means when the vessel is moving along the parallel of a latitude, or you can say when the vessel is moving parallel to the equator. Now obviously when the vessel is moving on the parallel of a latitude or vessel is moving parallel to the equator, the course of the ship can only be east or west. So that's why in parallel sailing, the course will be east or west, and whether it is east or west on a particular track depends upon the direction of the d-long or difference of longitude. When you look at the longitudes of the initial port and the final port, it immediately gives us the direction of the d-long, and whatever is the direction of the d-long, the same will be the course of the ship, either east 090 or west 270. The distance covered by the ship is given by the formula for departure. Departure is equal to d-long into cos of m lat. So we get the d-long between the two positions multiplied by the cos of latitude. In a parallel sailing scenario, the mean lat for initial and final ports will be equal to the latitude of both the ports, because both the ports are at the same parallel of latitude. So using this formula, putting the value of d-long and the value of latitude here, we get the departure, and this departure is the distance between the initial and final positions. We now move into our second rhumb-line sailing, that is plain sailing. The plain sailing gets its name from the fact that in plain sailing we use the concept of plane trigonometry. We use the three trigonometric ratios, cos theta, sin theta, and tangent theta, for a plane right angle triangle to get our course and distance. All these sailing methods, the rhumb-line sailing method, parallel sailing, plain sailing, Mercator sailing, as well as great circle sailing and composite sailing, basically allow us to calculate the course as well as the distance between any two positions on the surface of Earth. So in plain sailing, we basically involve our initial and final positions in making a right angle triangle, and when we solve that right angle triangle, we obtain the course and distance. Let us try to understand it using a diagram. Let's assume that the vessel is at this particular position represented by A. This is our initial position, and the vessel intends to reach to its destination, which is at this particular location. Destination is represented by P, that is our final position. Now we involve these positions in making a right angled triangle. Let us see the right angle triangle. You can see a right angle triangle involving our initial and final positions. Now in this right angle triangle, the side A to B which is the hypotenuse of this right angle triangle, is representing the distance between our initial and final positions. If we measure this distance on a chart, we will be able to get what is the distance between our initial and final positions. Let us name the third vertex of the triangle as C Charlie. Now, if you look at angle A of this triangle, angle alpha of this triangle, this is the angle between true north. Alpha to Charlie is a vertical line representing true north, and the ship's head. When the ship is moving from A to B, the ship's head will be in the direction of line or vector AB. So this angle is the angle between true north and the ship's head, which basically is the course of the ship. The vertical line or the vertical side of our triangle alpha to Charlie, if this is measured on a Mercator chart, this gives us the D-lat or difference of latitude between our initial and final positions. The third side of the triangle, the horizontal side, Charlie to Bravo, if you measure this side on a Mercator chart on the latitude scale, this gives us the departure between our initial and final positions. Now, a doubt would arise that the Bravo Charlie line, the horizontal line, can be also measured along the longitude scale. In that case, it will be the D long between our initial and final positions. But always remember that whenever we solve a right angled triangle, the units in which all the three sides are measured, they have to be the same. Now on a Mercator chart, we have two units or two scales. One is the latitude scale and another is the longitude scale. Now the distance is always measured on the latitude scale. 1 minute of latitude is equal to 1 nautical mile, 1852.3 meters. So this distance is always measured on the latitude scale. Also the side A to C, which gives us the D-lat between the two positions, is also measured on the latitude scale. So the third side also has to be measured on the latitude scale itself. So Bravo to Charlie is not measured on the longitude scale, but is measured on the latitude scale itself. When measured on the latitude scale, this gives us the departure between the two positions. The longitude scale and the latitude scale on a Mercator chart are not same. They have different dimensions. So remember that in plane sailing, for all the three sides, we use the latitude scale. Now in this triangle, we have the right angle at point Charlie. And the side opposite to the right angle is the hypotenuse. So distance becomes our hypotenuse. And considering the course angle, the side alpha to Charlie of the triangle becomes the base as it is connected with the angle, which is the course. And the side Bravo to Charlie, which is not connected with the course at all, becomes the perpendicular. So we have a right angle triangle. All the three sides are identified, hypotenuse, base, as well as perpendicular. Now let us apply the three trigonometric ratios on this triangle. We first apply the ratio of cos theta. In this case, it will be cos of course. Now cos of course is given by base upon hypotenuse. Base in our case is the D-lat, difference of latitude, and the hypotenuse is the distance. So from this trigonometric ratio, we get our first formula, which is D-lat is equal to distance cos course. So this distance from the denominator is taken to the other side, and the relationship converts to D-lat is equal to distance cos course. This is our first formula in plane sailing. Let us apply the second trigonometric ratio now, which is sine of course. Sine of course is given by perpendicular upon hypotenuse. Perpendicular in our case is the departure, hypotenuse is the distance. The sine course ratio gives us our second formula, which is departure is equal to distance sine course. The distance was in the denominator, it is taken to the other side, giving us the second formula for plain sailing. Departure is equal to distance sine course. Let us use the third trigonometric ratio, that is tangent of course. Tangent is equal to perpendicular upon base. The perpendicular in our diagram is the departure and the base is the d-lat, difference of latitude. So we get our third formula, tangent course is equal to departure upon d-lat. Now these are very, very important formulas for plain sailing. Any doubts up to here, beta?
So, what is the reason, sir, for using the right angle triangle?
Why we are using the right angle triangle?
Sir,
Because it
for
makes
plain
the
sailing.
calculation very, very simple and easy, beta. Without using trigonometry, there is no way you can find the courses and distances.
Yes, sir.
Okay, right?
And sir, and difference between departure and distance.
Okay, okay. Now, I believe this doubt comes from the fact that when we were doing parallel sailing, departure was equal to distance, right?
Yes, sir. Right.
Okay. Departure is basically the east-west distance between any two positions. East-west distance. Now, when you are doing parallel sailing, the positions are east-west of each other, beta. They are both on the same parallel of latitude. So departure becomes equal to the distance in that case. But when you are doing plain sailing, then these two positions are not on the same parallel. So departure here will not be equal to the distance. Here the departure is basically telling us that on a Mercator chart, how much A and B are far apart in the easterly westerly direction. That's it.
Understood, sir. Understood.
Okay, beta. Great. Let's move ahead. Once we are aware of these formula, we can use them to easily calculate courses and distances between any two positions on the surface of Earth. The plain sailing helps us to calculate two basic type of problems. If we have two courses, initial course and if we have two positions, initial position and the final positions given to us, latitudes and longitude is provided. Using this plain sailing, we can easily calculate the course and distance between these two positions. And second type of problem, if we are given a particular position, latitude and longitude, and we are given a particular course and a particular distance, using the initial position, course and distance, we can easily calculate the final position using these formulas very, very easily. This is a very simple form of sailing. We do not need to refer to any tables. We do not need to use any complicated formulas. Simple trigonometric ratios giving us these three simple formulas, helping us to calculate the course and distance as well as the position arrived using plain sailing. Now, a couple of things to keep in mind when solving plain sailing problems. First thing to note is that we need to make different triangles for different quadrants. Depending upon the direction in which the ship is going, depending upon the quadrant in which the ship is traveling, we need to make a different triangle. In the initial example, we saw the vessel was moving on a northeasterly course. So we used this particular triangle for our plain sailing calculations. This is the triangle for northeasterly quadrant. You can see the course of the ship is in the northeasterly direction. This side gives us the distance, the vertical side gives us the DLAT, the horizontal side gives us the departure. This is the course angle, and this is the triangle for the northeast quadrant. Second thing to keep in mind is that whenever we are doing plain sailing calculations, the course which is obtained is always the quadrantal course. It is not the three-figure notation or true notation course. It is the quadrantal course. In case of the northeast triangle, this course is north so many degrees east. If the vessel is moving in the southeasterly quadrant, the initial and final position, latitude and longitude, when we calculate the DLAT and DLong between the initial and final positions, it will immediately tell us what is the direction in which the ship is traveling. So if the ship is traveling in the southeasterly direction, we use this particular triangle. This side is the distance, horizontal side is the departure, vertical side is the DLAT. The course which is used here is the quadrantal course, south so many degrees east. If the ship is moving in the southwesterly direction, we use this particular triangle. Initial position is here, final position is here. Vessel is moving in the southwesterly direction. This is the course angle, the quadrantal course, south so many degrees west. If the vessel is moving in the northwesterly direction, we use this particular triangle. You can see the ship is moving in the northwesterly direction. This angle is the course angle, quadrantal course, north so many degrees west. So whichever quadrant or whichever direction the ship is traveling, we need to use a appropriate triangle for that particular quadrant. Also, the course which is obtained or the course which is used in the formula is always the quadrantal course, not the three-figure notation course. Now there is one limitation which is there in the plain sailing method. And that limitation is that plain sailing is used only for distances less than 600 nautical miles. The reason for that is when we are doing plain sailing, we are solving for courses and distances using plain trigonometry, but the vessel is moving on the curved surface of the earth, a 3D curved surface of the earth. So moving on a curved surface, we are using the formulas which are meant for plane surfaces or plane trigonometry. This is bound to bring in some error in our calculation. Now till the time the distances are small, to be precise less than 600 miles, these errors are small, insignificant, and they can be easily neglected without any appreciable loss in the accuracy. But when the distances become greater, more than 600 nautical miles, the error which comes in our calculation also becomes significant and can no more be ignored. So we use this form of sailing for distances less than 600 nautical miles. What is to be done for distances greater than 600 nautical miles? For that we use our third rumb line sailing, which is known as the Mercator sailing. Any doubts up to here, beta? Great, very good. We now move to our third rumb line sailing, which is the Mercator sailing. We have seen that plain sailing has a limitation of 600 nautical miles, Plain sailing can be used for distances less than 600 miles. If the distance becomes more than 600, it gives appreciable error, significant errors in the answers. Now, Mercator sailing can be used for any distance. Mercator sailing is equally accurate for distances less than 600 as well as greater than 600 miles. Or in other words, you can say that when we do Mercator sailing, the curvature of the earth is accounted for, giving us more accurate courses, distances, and positions. Now, a very simple way to understand Mercator sailing is that when we are making a Mercator sailing triangle or diagram, we convert to the longitude scale on the Mercator chart. By converting to the longitude scale, we are able to obtain the required accuracy. Let us try to understand it using a diagram. We have seen the plain sailing triangle. You can see this plain sailing triangle ABC coming up on the screen. Angle A is the course angle. Side AB was the distance. Side alpha to Charlie is the DLAT. And side Bravo to Charlie was the departure. All the three sides of this triangle were measured on the latitude scale. Now, in a Mercator sailing triangle, we convert to the longitude scale. You can see this blue color triangle shown in the diagram now. This is the Mercator sailing triangle. Let us show the vertices by delta and echo. So alpha, delta, echo is the Mercator sailing triangle. Now, since we are using the longitude scale, when we measure this distance echo to delta on the longitude scale, it gives us the d long between our initial and final positions. When we measure the vertical side, that is alpha to echo, on the longitude scale, this gives us what we call as DMP, difference of meridional parts. If the side was measured on the latitude scale, it gave us the DLAT. But if the same side is measured on the longitude scale, it gives us the DMP, difference of meridional parts. Meridional part is basically 1 minute of longitude. So DMP between the initial and final position is basically the number of times 1 minute of longitude can be placed between our initial position and our final position. Now, in this Mercator sailing triangle, we have only one additional formula, and that formula is using the tangent ratio. Tangent of course is equal to d long upon dmp. So this formula in plain sailing was tangent course equal to departure upon dlat. It has been converted to tangent course is equal to d long upon dmp. D long can be easily obtained from the chart itself. In fact, we have our initial position and final position given to us. We can obtain the D long between the two positions. The DMP is obtained from the meridional parts table in the Norris nautical tables. As I told you, DMP is the number of times 1 minute of longitude can be placed between the initial latitude and the final latitude. And this is found out using the meridional parts table in the Norris nautical tables. I will show you the meridional parts table in the coming slide. So once we obtain the DMP and the D long, they can be used in the formula to obtain a more accurate course. Now, once the course is obtained, to calculate the distance. Now, distance cannot be measured using the longitude scale. So for distance, we need to go to the latitude scale because 1 nautical mile is equal to 1 minute of latitude and is equal to 1852.3 meters. So there is no way distance can be measured on the longitude scale. So for calculation of the distance, we go back to our plain sailing formula. DLAT is equal to distance cos course. The course has been obtained using the Mercator sailing formula. Same course is used here. The DLAT between the two positions is fed into the formula and the distance can be calculated. Now, since we are using the plain sailing formula, how do we obtain a more accurate distance? A more accurate distance is obtained because the course which we have used in this formula is obtained from the Mercator formula, not from the plain sailing formula, and this course is a more accurate course. When you use a more accurate course, the same formula gives you a more accurate distance. Any doubts up to here, Peter? Great. Now you may note that in Mercator sailing also, we have used the concept of plane right-angled triangle. We have used the tangent ratio. So how are we able to obtain more accurate courses and distances using the Mercator sailing? How is the curvature of the earth accounted for? The curvature of the earth is accounted for by including the DMP, difference of meridional parts. The meridional part basically include the curvature or basically account for the curvature of the earth, giving us a more accurate answer. Mercator sailing, as I told you before, can be used for any distance less than 600 or greater than 600 miles, and it gives us the accurate courses and distances. Let us now see how do we obtain the DMP, difference of meridional parts between any two latitudes. For this we use the Norris nautical tables. Inside the Norris nautical tables, you have a table for meridional parts of the terrestrial sphere. Now in this meridional parts table, you can see the latitudes are mentioned on top on the horizontal axis. You have all the degrees of latitudes and you see the minutes mentioned on the vertical axis. So you enter with the latitude of the place. For any particular latitude and longitude, you can see the meridional parts from this table. Once you obtain the meridional parts for your initial latitude and the final latitude, these meridional parts are combined together to get the DMP. When combining together, if the initial and final latitude are of the same name, the DMP is obtained meridional parts of higher latitude minus meridional parts of the smaller latitude, bigger MP minus smaller MP. In case the initial and final latitudes are of the opposite names, the positions are in the different hemispheres. In that case, the DMP is given by meridional parts of the higher latitude plus meridional parts of the smaller latitude. Or in other words, the meridional parts of the initial and final positions are added up to get the DMP. This is exactly like how do we calculate the DLAT, difference of latitude between two positions. Same name, we subtract bigger minus smaller. Opposite name, we add both of them to get the DMP. Any doubts now, beta?
So ये vertical वाला is the longitude.
You mean to say in the table, beta?
हाँ sir, in the table.
No, in the table on the horizontal axis, you see the degrees, beta. 10 degree, 11 degree, 12 degree. And on the vertical axis are the minutes.
Minutes, okay, minutes.
Right? So let us say, for example, 10 degree and 10 minutes. The meridional parts will be 609.10.
Okay, sir. Okay. वही minutes cut out.
Okay, all right. Now, those of you who are not having the Norris table with them, I have shared a selected pages, 25 pages of the Norris table by the name of, I've shared a PDF file with you. It has about 25 pages or so. So these meridional parts are included there in that. You can take a printout of that and you can refer to it when required. Right, beta?
Sir, one out of context doubt. In examination, they will give the Norris table or we have to carry?
Yes, beta. They will provide you with the Norris table. If you want, you can carry your own also, just as a emergency backup. But usually, all the MMDs they provide you with Norris tables.
Thank you, sir.
Okay, great, beta. So I hope the Mercator sailing, plain sailing is revised now. All revised. सब याद आ गया बेटा?
Yes, sir.
Yes, sir.
Okay,
Yeah. याद भी आ गया और थोड़ा और update हो गया, sir.
very good, beta. Great.
Sir, how often do we use this Mercator sailing in questions?
ओके सी बेटा, क्वेश्चंस में मर्केटर सेलिंग पे जो यूजेज आता है that is basically in these GC and composite questions where they tell you to compare the two distances. Okay? Because when you do GC and composite, the distances are huge, running into thousands of miles. So plain sailing cannot be used there. So that is where we have to use the Mercator sailing. If somebody uses plain sailing there, the question principal error, it will be a principally wrong question. So that is where it is basically used. In other questions, usually Mercator sailing is not required. In plotting questions or in other type of questions, plain sailing does the job. Mercator will
Yes.
not be required there.
So in that vertex questions where we are using composite sailings and all, everywhere we use a plain sailing formulas only, sir.
In composite sailing, you are using parallel sailing, beta.
Parallel sailing. Sorry, parallel sailing.
Yeah. In composite, you are using parallel.
Yes,
In
sir.
plotting questions, or if anywhere you need to find out the course and distance for a short run, you will use plain sailing.
Okay, sir.
Sir, I have one query. I just missed some conversation. I could not hear. When you said DMP, what conditions will we use the DMP, sir? Actually, some phone
Okay.
calls are coming, so I can just miss this point, sir.
No problem. You did not miss much. DMP or Mercator sailing is used in those scenarios where the distances are more than 600 miles.
Okay, sir.
Okay. Because when the distance increases more than 600 miles, plain sailing starts giving us errors in the answers and the errors become appreciable. So that is where we use Mercator sailing.
Okay. Okay. Thank you, sir.
So, sir,
Oh.
to understand more, just to solve, can we PRACNAV we can solve the Mercator sailing once, or you will be having some questions now?
No, beta, you are exactly right. What you do is just to practice some basic questions. You have one exercise in PRACNAV for plain sailing and one exercise is there for Mercator sailing. So practice some questions from both. Okay. So practice some questions, only those much with which you gain confidence and you are confident that you will do these calculations right. Because these calculations are going to make small parts of our questions. Like हमने देखा Mercator sailing is required in some of the GC composite questions where a comparison is made. Similarly, plain sailing will be required when we go to plotting. Okay, so practice few questions to gain confidence. That's it.
Okay, sir. Thank you.
Okay, all right. Okay. Yeah, question number 4 is now complete, beta. So you complete the assignment which I have given you. And once your assignment is completed, then you can go to MMD past papers also. And you can attempt question number 4 of any paper. And if you get stuck, not getting the answers, not getting the way how to questions getting solved, how the question is to be solved, you can share it on the group. So question number 4 is now completed.
Okay, thank you, sir.
Okay, all right. So beta, next we will be moving on to question number 5 and 6, which involve celestial navigation, site solving, these concepts. So I will be first covering up the basics of nautical almanac, what all information is there available to us in the almanac, and some basic concepts, correction of altitude, chronometer error, chronometer ambiguity, then calculation of amplitude and azimuth. These basic concepts we will be covering up. I am not picking them up today, so we will keep them for the next class. Okay, so go ahead with your practice of GC and composite beta. Try to complete the GC composite assignment before the next class, because next class शुरू हो जाएगी तो आपको फिर और homework मिलना शुरू हो जाएगा. You will get the practice questions for amplitude azimuth practice करना पड़ेगा आपको, ABC method, then altitude correction आ जाएगा. So try to complete GC and composite before the next class. That will keep you on track.
Okay, sir.
Okay, all right. So we close out for today, beta, and I will see you in the next class. Before the next class, if you get any doubts in the GC composite assignment, कोई भी doubts अगर आते हैं, so just post them on the group so that I am aware of what doubts are there. If possible, I will send you the solution or a hint how it can be understood over the group itself. If not possible, then I will discuss it in the next class.
Okay, sir.
Okay, beta. So
सर
great.
वो
हाँ,
पोलर ट्रायंगल का सर आप वो जो क्वेश्चन.
so I'll send you one question to practice.
ओके सर, थैंक यू.
Okay, all right, beta. So great, beta. We call off for today, and I will see you in the next class. Bye.
Okay, sir. Good night.
Thank you, sir. Good night.
beta. Good night, beta. Bye bye.
Thank you, sir.